In this video tutorial, we are going to build a random graph, arrange it with the layered layout algorithm, and run animations on the path between any two nodes the user has selected. The path can be the shortest or the longest. Each time a button is pressed, a new random graph is generated. We create an empty project, which we name Pathfinder Demo. The project is in C# with .NET 6. We will install the diagramming libraries from NuGet. Let's search for MindFusion. Here it is. The installation is successful. Let's start coding our app. First, we need a class variable for the diagram. The diagram needs a diagram view to render itself onto. The diagram view has docstyle of fill. Let's set a colorful background of the diagram so we can see it on the form. Each diagram view has a diagram instance assigned to it. The behavior property specify how the diagram reacts to user interaction. In this sample, we want the behavior to be modify, which does not allow creation of new diagram items. However, until we are ready with the graph, let's not change the default behavior, so we can see interactively the result of some settings and styling we are going to apply. We create an instance of the theme class, which will be used to style the diagram. First, we create a shape node style. Then we initialize two solid brushes, one yellow and one blue. We set the default brush for nodes to be yellow. We set custom colors to the stroke and shadow brush properties of the shape node style object. Then we register the style with the theme. The next style will be for diagram links. It uses custom brushes for the stroke, head stroke, and the interior of the arrowhead shapes. We register the style with the theme as well. Finally, we assign the theme instance to the theme property of the diagram. Our nodes are drawn yellow now. The links are green. Fine. Let's start building the graph. We create a random number with seed 42. Then we define an empty method called createNodes and links. This method will be called each time we want to generate a new graph. That is why we first clear all items from the diagram. Then, in two nested cycles, we create a random collection of nodes and links among them. The head shape for newly created links is triangle. Now, if we run the sample, you can see that the nodes and links are created correctly, but are not arranged properly. Let's use a layout algorithm to change that. We define a new method called applyLayeredLayout. We will use the layered layout for arranging our diagram. We create an instance of it and we add a bit of a margin around the graph. The direction is straight. The orientation is horizontal. The layout allows us to customize the distance between nodes and layers, and we increase both values to give the graph more space. We also customize a few more properties and call the arrange method to apply the layout. Let's not forget to call resize to fit items on the diagram, which makes sure that the new graph is fully visible. The graph looks lovely now. Let's increase the count of layers to 10. I think 8 would do fine. Let's leave it that way. Now we will handle the node clicked event, where we will color the selected two nodes in blue and use them for path finding. We get the clicked node from the event data. We set its brush to be blue. We need to define two more class fields. One is for the count of clicked nodes, which will be incremented each time a node is clicked. We also need to keep track of the clicked nodes, so we define two more class fields of type shapeNode. If the count of clicked nodes is 1, this is the start node. If it is 2, this is the end node. We make both of them blue on click. If the user clicks a third node, we need to clear the selection from the previous two nodes. The clicked node becomes the current first node, and the clicked node's counter is reset. Let's see the code in action. Everything seems to work fine so far. We will add a new method called Animate Graph. We check that the two nodes are not null, and then we initialize a new instance of the Pathfinder class. It will help us find the shortest or the longest path between two nodes by simply calling a single method. Let's start with the shortest path. We will extend the code later. Once we get the path, we have to check that it is not null, which happens if no path exists between nodes. If a path has been found, we run the animation. For the animation, we choose the Path Animation class. There are various animations supported in version 7 of the diagramming library. We will use Path Animation, which requires an array of points. We will add to this array all control points of the links from the path. Some links might have multiple segments and will have several control points. We will create a small circle node that will be animated along the path. We will remove it from the diagram items once the animation is finished. We initialize a new instance of the Path Animation class and provide as first argument the array with animation points. Then we create a new Animation Options instance, and we specify the duration of the animation. The duration depends on the count of items, so longer paths will have longer duration. We need to assign the animation to the node and then start it. Let's not forget to handle the animation complete event, where we will remove the dummy node from the diagram items. Let's call the Animate graph method when the selected nodes are exactly 2. And here it is. The dummy node goes along the shortest path between the selected nodes on our graph. Excellent. Let's finish our application by adding a panel with a few buttons at the top. There will be one button to generate a new graph and 2 radio buttons for switching between shortest and longest path. We have to edit the code in the Animate graph method with a check. Which of the 2 radio buttons is clicked? Let's see how it works. Everything looks fine. The last addition to our project is Event Handler for the standard button that will generate a new graph. We just call the methods to create diagram items and arrange them. We also reset the counter and the selected nodes. With this, our video tutorial is finished. We've just built a WinForms application that finds the path between two arbitrary nodes in a graph and animates it. Thank you for watching, and thank you for your interest in MindFusion Developer Tools.